Okay, I had some issues with my microphone here. Figures 19 and 20 we've done in the previous videos. 21 and 22 look familiar. Actually, all of these look pretty familiar on this page. So we'll cruise through them and see how far we get. So, all right. Now fly back in. So basically rectangular block, kick back 30 degrees, kick back 30. No real right or wrong way to go about that. I like the right side geometry. And we're in metric, so new part metric, right plane, open up the sketch. We have the angle back, so let's just start from the origin up over a little bit of a flat to the angle, watching some of those inferences, and the little step, and back in. All right, so that needs to come up vertical, and we can give it the overalls 50, height of 45. All right, missed by a little bit on that one. 7 millimeters by 9 millimeters on the lower chamfer. And then 15 millimeters to the step. And we had 30 degrees off of the angle, 15 millimeters off of the height, and 30 degrees. Well, and putting that dimension in, let's go from there to there, pick the angle, and we'll go 30 degrees. All right, so basically looking at those angles. All right, 8 millimeters by, and looks like we have 32 millimeters from the edge. All right, so extrude that out. And we're going 80 millimeters overall. Okay, so if we open up a sketch anywhere on the geometry, then the choice is to go with an open profile or a closed profile. So if I go with the open profile, I just have to make sure it's connected. I put the pencil down, and I can trace through everything that needs to be cut. All right, so 30 degrees, endpoint, vertical leg, and 25 millimeters back. 25 millimeters back. Let's see if that works out. 25.98. Interesting. So one of those has to have priority. So still within plus or minus millimeters quite a bit. And we're not really given anything on the other side, so well, let's go ahead and cut it. And looking at the side to cut, then we're going to be through all, defaults to through all both, and removes the material. All right, looking at 20, we have symmetry about the center line. And a couple of the notches. And we're still in metric. All right, so line, vertical, infinite length. That puts us into to position to establish the symmetry. So up, over, back, a little bit of an angle. Watch out for the inferences, up and over. Okay, window pick, mirror entities. And between the 2 points, we are 20 millimeters. And overall is 60 millimeters. Because of the symmetry, we can double check our lengths, but that should be 20 millimeters. Let's see, we had 18 millimeters to the step, 13 millimeters to the start of the angle. And our overall dimension, see, 45 is the depth, 18 and 22, so that would be 50, 40. All right, so angle, or the face, that goes to 20 millimeters. And we had 5 millimeters for the depth here. I'll just kind of keep working through this. And 45 degrees. All right, so 13, and then where do I get to the base? Okay, so we have 18, 10 back, 13 to the step, 18. Well, it looks like it's going to have to go through that point. So let's go ahead and generate another line and see if that will pull it in. But we really don't have the length. Okay, I would have sworn that we pulled a dimension off of that previously. So yeah, that really didn't help. Depending on that length, which we don't have. And if we're to tell it that this is 20, it's just going to go to a driven dimension. So let's go with the, well, we already got that dimension, so that one will go driven as well. So it really comes down to those angles. Oh, the 60 degree. Okay, missed that one. Okay, so it's hiding from me in plain sight right there. Alright, so that looks better. Features, extrude boss base, and we're going 45 millimeters. Go for the step. Go into the right plane. And starting from the peak, down through the step. And I picked up a midpoint. Alright, so the problem there is that I really don't want that midpoint. My sketch is back here, so let's go ahead and show. And with projecting, well, there's not anything there that I can really pierce. But if I can project the endpoint, I can probably get it to go horizontal. And then we'll go back to the right side. Make sure that that's connected and horizontal. So that looks pretty good. We're going back 10 millimeters. And we have an angle of 105 off of the vertical. Okay, so features, extrude cut, again with an open profile. I need to verify that the flip cut is pointing in the right direction. In this case it is not, so we can click on the arrow or come over to the checkbox. And this is going to be a through all both. And that gives the step. Okay, so we can hide. Go into the sketch. And got the coincident there, but missed that one. Those are going to be collinear. And we had, now that's going to come back to the intersection. So let's go with center line, origin to midpoint, a window pick, and mirror entities. And then we'll extrude cut 10 millimeters. Alright, so last video that I did of this one kind of pointed out that all of this geometry is manufacturable until we get to this notch. One of these corners is going to need to have a radius in it, or we're back to the Sync or EDM or some other manufacturing process beside traditional machining. Alright, 4-20. Let's fly in the next piece. Alright, so this one we will go to the angle. There's only a handful of ways to really approach this one, so going into the geometry, and this is a part inch. So on the top plane, open up the sketch. And I think I got ahead of myself. I really needed the angle there. Yeah, so let's just undo, and I'll go for the right plane instead. All right, I'm still going to go with the rectangle, because as a strategy I do like getting those 4 lines and then just removing one of the horizontals, or vertical as the case may be. Overall is 3.5. 1 5/8, 1.63, and leading edge 0.63. Okay, so I usually have a discussion about the rounding, since we're showing 3 decimal places, that depending on the level of tolerance and precision that you need, even though we're basically going to define this in terms of 2 decimal places, we would carry it to 3 so that we don't end up with rounding errors in the assembly. So that's a decision that gets made up front, and or one that you are forced to make after you get it into the assembly and realize that things aren't stacking up or are misaligning. Alright, so sketch, and rotate around just a little bit, check out which way the angle is going. I'm going to convert the 2 edges in. So kind of double check that that was the intended result. And we'll come down at an angle and over. All right, and then we'll look at it from the bottom again. One line goes that way, one line goes that way. All right, so missed, and that gap will be a problem. So we'll pull it over until it goes coincident. Backside is 1.75. Front side is 0.5. And then the steps, 1.25. And our gap, 1 inch. Okay, so when we go to extrude this, we're going to be using the contours and regions. We could trim out our geometry, but let's see, let's go ahead and reverse. But with the contours and regions, it's about as easy just to leave it. All right, and overall height 2.5. And the intersection, our positive into a positive, because it's merged, is no net gain in mass. It gives us the finished geometry. All right, save. All right, going over to the 422. Pretty much, if we want to include the whole geometry, we could go ahead and in these sketches. Otherwise, we could go to the whole wizard. So, new part metric. We'll go with the top plane. Would like it to be on center line. So going to midpoint, 100 millimeters by 40 millimeters. And we're going to have the 3 holes in place. All right, and it's 20 millimeters off, so I can go without the dimensions as long as I have the center line to set the midpoint and to set horizontal and to mirror. Okay, and I think I forgot equal. So these are all 20 millimeter holes. And so the center one didn't update, so we'll go equal. And then we need a separation. So 2 times 30 between the holes. And then this will extrude out a total of 10 millimeters. All right, going back into the top plane. Pick up our midpoint. The width of the angle, well, let's see, I was going to try to, I was going to bring that one up, but I was going to try to get all of the sketch and the hole into one segment. So double check my rotation. So if I go this way as opposed to extruding it up, normal 2, we have a width of 40 and height to the lower ledge of 40, so an overall of 55. Now we could go to the 40 and just sketch on that top plane too. So, all right, so 40 wide, 40 tall to the step. And then the circle, pick up the origin as a vertical. 24 millimeters times 2 holes. And distance, kind of the way that it shows it 20 millimeters off of the ledge. Looks like it's going to be too tall. And if we go the other way, so let's fly this in. So that dimension from the edge to the lower. And actually, that would have been 50 because there it is. It's coming back over to the intersection. All right, so we can double click on that. Or I can try to, if we highlight and I can grab this handle, I can bring the handle up to the edge. And it will modify the extension lines. All right, so I inferred, but it did not apply. So I'm going to have to go back and force the relation to the origin to be vertical. Features extrude 10 millimeters going away. Give me the geometry. All right, sketch on the top. Same width. We'll bring that corner over until it goes coincident. Jump back into our dimension, and the overall is 5.5. Alright, so I don't want to infer any of the circles if I can help it. So 24. We have a distance off of the leading edge of 25. Yeah, it ends up being pretty well on center. And then vertical. Alright, so that lines up. And then the feature is extrude 15 millimeters. Alright, and that gives us our shape. Alright, so from a manufacturing standpoint, there's probably enough meat here that unless there's something structural, I would consider making this in 2, maybe 3 pieces, and counterbore holes or countersunk holes to bolt it together at the bottom, depending, rather than removing all of this material and having to manage all that geometry. Alright, next one, 423, a couple of steps off center. Oh, just need to save that one. Alright. Part metric. We'll go with the center. Okay, to midpoint. Jump back into the line by hitting L on the keyboard. So one small side, one taller side. Throw some dimensions on it to start bringing everything in. 100 by 15 and 30. Let's go ahead with the select midpoint, and we'll make that vertical. And then our dimension, let's see, 20 centered, looks like 40 overall, and a height of 50. Alright, features, extrude boss base, midplane, and depth of 50. Alright, so the 20 millimeter, 30 millimeter, there's no depth call out, so the assumption is that these are all through holes. So I can do that at one level. So the 30 will pick up from the origin at the center. Okay, the 2 smaller holes will make horizontal. Go back and pick up the perimeters and make those equal. Set those to 20 millimeters. Let's see, from the outside. All right, so they move together, but still independent of the origin. And they're not specifically set. So we'll go with 13. And it was, 13 both sides. All right, so I could have made that symmetrical, but put them in. Extrude cut, through all. Clear out the geometry. All right, and then rectangle. And we'll pick up the other side of the circle. 20 millimeters in width. And 15 millimeters in depth. Alright, don't think I missed anything, so call that one good. Alright, 24. Basic V block could go either way. The nice thing with the step going to the right, or we could go with the symmetry. Yeah, it could go either way. So let's go with the V block front, and then we'll cut the notch and the hole through at the same time. And those are in inches. Front plane, we're going to use the symmetry, so center line, vertical, infinite length. Go to the origin. Pick up our line, L on the keyboard. Come back and make the V. And then we'll window pick, mirror the entities. 4 inches by 3.5. And then the V was centered 2 inches by the center line. And we'll go 1.5 for the depth, and 1/2 inch out on the edge. Okay, this can be extruded. Let's go mid-plane to a depth of 2.5. All right, right plane. Pick up our circle. Let's go with the vertical relation first. And the diameter was 1.5 through. 1.5 off of the bottom. And then the notch we could make separate, or since both of these are going to be through all, we'll just go ahead and include it. 1 inch by 0.5. Features, extrude cut, through all both. Make sure that it intersects the geometry going both ways. All right, 25, that one's new and different, but basically cylinder, notch out, angle. We've done that one before, perpendicular to A. That looks familiar, that looks familiar. That looks familiar, that looks familiar. All right, so a couple of revisiting from chapters 2 and 3. All right, so we're going into metric. Let's go with the top plane, and we'll generate our cylinder, our tube. All right, so 80 millimeters on the diameter, 50 millimeters on the ID. All right, so if we wanted this to be a wall thickness of 15, for example, we could click both cylinders. Or I can hit escape and get back out of it. And we're going to extrude that out 70 millimeters. Okay, so front plane, open the sketch. And we're on center line. So down and over. Going to leave that as an open profile. And we have 20 at the base, 20 at the top. Features, extrude cut. Check the direction, and then through all both. All right, going to the top. We get our rectangle started, pick up coincident back to that interior edge. We can go tangent to the outside. And what that does is, regardless of if we need to grow or shrink this this cylinder, we'll be able to keep it in contact with the edges. Make an extrude cut 10 millimeters deep. That's an interesting graphics trick. And that gives us our shape. Alright, so revisiting 4-26. If we do the whole thing, so 40, 50, now we'll just add on to the end of it. And then go through. And this is in metric. So from the front plane, up, over, oops, missed something. Got to get the angle in there. And missed that one by a little bit, so we'll go back and add the horizontal relation. Alright, so the auto scaling, even though I got that one a little bit big, when we auto scale, it'll bring it back into better focus. 45 degrees, 50 millimeters on the height. We had an additional 15 to the edge. So 40, let's go 55. And then features extrude, 60 millimeters deep. And I'm going to have this one go the other way. All right, so we could draw the rectangle on this end, rectangle on top, rectangle on bottom, rectangle on the back. We have plenty of choices here. So I kind of saw the top first. So 15 millimeters deep. And 18 millimeters off of the edge. And then that is a feature extrude cut through all. Pick the next angle. Alright, so 20 through, perpendicular to A. And it'd be nice if they would have carried that notation through a couple of the other examples, other projects. 18 off of the base, and 30 would be on center line. So intent is to keep it on center line, so midpoint and vertical to the sketch. Features extrude cut through all, and we're going to get that little half moon, half arc relief on the back side of the part. All right, let's take a look at the next one. Okay, 4-27, a couple of the arc and the intersecting cylinder. And we're in metric. So let's go with the top plane. And we'll pick up the rectangle and come off with the line. That looks like it doesn't quite make it to the intersection, so this goes to construction geometry, and then we'll use the construction geometry for our arc. Make sure that it picks up the center line, and we'll go ahead and put the hole in as well. All right, so the advantage of having the contour and region is I can include that geometry, and that kind of helps with the visualization of where the geometry is going to intersect. Had a radius of 15, so that's going to give us 30. And to the center was 35. And then our through hole was 13. Alright, so first piece is extrude boss base, pick our region, make sure we get in between the center line and the arc. Alright, and then extend out, make sure that we can see the sketch. Pick Pick our next piece of geometry. We'll drag a little ways. And it was 12 two places, so 24 and 13 for 37. Sketch the whole location. And that's a diameter of 16 millimeters. 12 millimeters off the edge. Or, if we needed to always keep that centered, I can undo the dimension. I've lost my diameter. But we'll come off of the midpoint, go to a coincident, midpoint to midpoint, or midpoint to coincident, and then pick up the intersection. All right. Didn't necessarily need both of those, but visually it makes sense. Extrude cut through all. And we'll go ahead and save it.